Hello everybody, so welcome to part 7 of toxin sequestration theory. This is my new theory of cancer. I've already put out 6 other videos on it. You can feel free to watch those. But just to recap, the idea is that our theory is very different from the mainstream, to say the least. We do not view cancer tumors as selfish, uncontrolled, and malignant growth. Rather, we view them as the body's defense mechanism against toxic overload. And furthermore, we do not even view cancer as a disease. Of course, there are other diseases that are real, but cancer we recognize as a symptom rather than a disease. It is a symptom of toxic overload, and cancer tumors are built intentionally by the body in order to protect itself from the toxic overload. In particular, the body builds cancer tumors as extra tissue to store and process toxins that would otherwise damage the body's tissues and create disease. And we've talked about a whole long list of toxins that are stored or processed inside cancer cells. That includes things like glucose, fructose, ammonia, oxalates, heavy metals, seed oils, excess iron, excess estrogen, microplastics, ethanol, cigarette smoke, mycotoxins, and the list goes on and on. All of these I've discussed how they are preferentially sequestered and either stored or processed inside cancer cells. So it very much looks like cancer tumors are acting like a detox organ. They are an organ very similar to the liver. In fact, a lot of the detox pathways that cancer tumors run are very similar to the detox pathways inside of the liver. So it looks like indeed, the body builds a cancer tumor as kind of like a backup liver. That's the basic idea of toxin sequestration theory, and I'm very excited about it. And I've also sort of extended it to explain other phenomena like metastasis and cachexia as also defense mechanisms that the body is doing. And it's actually very interesting that there's now kind of like a long list of quote-unquote diseases that are actually the body's defense mechanism. So basically things like cancer tumors, cachexia, metastasis, those are all things that in the mainstream, those are viewed as diseases. And I'm reinterpreting them as the body's defense. And in this video, I'll add another one to the list, and that's sort of mitochondrial quote-unquote dysfunction or downregulation in cancer cells. So I'm going to talk a little bit about the altered metabolism in cancer cells. So this is very prominent in Thomas Seyfried's theory of cancer. Basically, he views cancer as a mitochondrial disease where the mitochondria are defective or broken inside of cancer cells. And I'm going to actually argue that that's not necessarily true. Rather, it looks like the mitochondrial function is downregulated intentionally by the body in order to protect the body from producing too much oxidative stress, so too much reactive oxygen species. Because the basic idea is that in order for a cancer cell to function as a toxin storage vault, we can't run the normal metabolism that we would normally run in a normal cell, because all of these toxins that I've talked about basically end up producing excess reactive oxygen species if you run your normal mitochondrial function. And so if you try to metabolize the sugars, glucose, fructose, in the presence, with normal mitochondrial function, you'll end up generating all kinds of ROS. The same is true with deuterium. Stephanie Seneff has argued that if you have a cell full of deuterium, which is a toxin, and you tried to run your mitochondria in that environment, you would just generate tons of reactive oxygen species. So it just doesn't work. In other words, having a ton of toxins stored inside the cell is not compatible with running your mitochondria at full speed. And so that's why mitochondrial function has to be downregulated inside of cancer cells in order for them to act like a storage unit. For them to be repurposed as a storage vault, then mitochondrial function has to be downregulated. So that's sort of providing a different perspective. Thomas Seyfried views it as the mitochondria are damaged or they're defective. And I'm saying that it's actually a downregulation. It's something intentional. They're not damaged. So, of course, mitochondrial damage can be a correlation. So it is true that if you have way too much ROS inside the cell, you can observe some mitochondrial damage. And that's the same thing that's true for DNA damage. Just like the mainstream. Think about the mainstream theory where they say, oh, cancer is caused by genetic mutations, damaged DNA. It's true that if you have a bunch of reactive oxygen species floating around in the cell, they can damage DNA. But that's like a side effect. That's a byproduct. It's not the driving force. It's not the reason that the cancer cell is cancerous. It's a side effect. And same thing here. I'm not saying, you can have a little bit of mitochondrial damage and a little bit of DNA damage just because there's ROS floating around inside the cell, but it's not the reason for the metabolic changes in the cancer cell. So what's really going on? So in Seyfried's theory, there are 3 key hallmarks of cancer metabolism. That is the metabolic changes inside of cancer cells. And number 1 is the so-called Warburg effect. The Warburg effect is basically a different way of metabolizing sugar. Instead of glucose being metabolized in the standard respiration way in the mitochondria, rather it's metabolized through fermentation. The second phenomenon is glutamine addiction, where the cancer cells, rapidly import tons of glutamine in order to fuel their growth, according to Seyfried. And then the last one, as I said, is this, quote unquote, mitochondrial dysfunction, or lack of mitochondrial ability to do what they normally do. So those are the 3 kind of hallmarks of Thomas Seyfried's view on metabolic changes, and so we can go sort of one by one and kind of dissect them and sort of figure out what's really going on here. But let's start with the Warburg effect. So in the Warburg effect, the cancer cell does fermentation of glucose instead of respiration of glucose. Now, normally, under normal conditions, if you could get 36 ATPs, that's the unit of energy, out of a single molecule of glucose. If you just did the normal respiration of glucose in the mitochondria, 36 ATPs, that's a lot of ATPs. But if you switch over to fermentation, you only get 2 ATPs out. And so this is where things get kind of funny, because everyone talks about how glucose is the fuel source for cancer growth. Well, if glucose was the fuel source for cancer growth, why the heck would cancer want to only extract 2 ATPs out of it instead of 36? That's a 94% energy loss. 94% of the energy is wasted by switching the metabolism from respiration to fermentation. So something is going on there. The cancer cell is apparently not really caring about the energy that much, because they're wasting 94% of the energy of sugar by switching their metabolism. And that implies that cancer is not trying to act like a power plant. It's not trying to just pull in chemicals that will give it tons of energy. Rather, it wants to reduce oxidative stress. And it chooses a less efficient pathway, fermentation, from an energy perspective, in order to quickly and safely detox glucose. It's all about being safe, because it knows that if it tried to run the mitochondria with glucose, it would generate ROS. And so instead, it says, well, I want to do this safely, and I'm going to take the energy hit. I don't care about energy. I'm just going to basically try to detox it very quickly and safely so that I don't generate any reactive oxygen species. So it's all about reducing the oxidative stress for the body. It's protecting the body. And so that's my argument for why the Warburg effect occurs, which is that it's a way of safely detoxifying glucose without producing oxidative stress. And secondly, there's the glutamine addiction. So glutamine, like I said, is rapidly pulled in by the cancer cells. They dramatically upregulate their glutamine receptors. they're glutamine transporters in order to pull it in. And so what's going on here? And I've already talked about this before in my previous videos. I view this as a key aspect of ammonia detoxification. Ammonia is a toxin. It's highly toxic, creates tons of ROS, and but you can't transport ammonia in the blood. It's produced in the muscle cells, and then the muscle cells have to send it from the muscle to either the liver or to the cancer cells for it to be processed. And the body's not going to let that ammonia go straight into the blood, because that'll damage the body's vital organs. It'll cause brain damage, it'll cause heart damage, it'll cause vascular damage. So it packages it safely in glutamine. Glutamine is the body's carrier of ammonia. And what happens is that inside the muscle cells, that ammonia is stuck onto a glutamate molecule to produce glutamine, and then the muscle cells send the glutamine off into the blood. The cancer cells or the liver cells will pull it in and then rip the ammonia off the glutamine in order to detoxify it. And it's important to note that this is not for growth. In practice, glutamine is a relatively poor and unreliable substrate for energy production and biomass synthesis. It's not really a good molecule for energy and growth. So that's not really what it's being used for. It's being used as a carrier of a toxin. And the cancer pulls in the carrier and then rips off the toxin and then detoxifies the ammonia. So that's my reinterpretation of the second point of the metabolic changes. And then finally, the last point is that the mitochondrial function is sort of dysfunctional or broken, right? So that's Seyfried's view, and I'm reinterpreting it as it's downregulated intentionally. In particular, there is a process in metabolism which is called oxidative phosphorylation, and that's basically the body's way of efficiently getting energy out of fuel sources. And I'm saying that cancer cells dramatically downregulate their oxidative phosphorylation that happens in the mitochondria. I gave this a name. I call it protective OXPHOS downregulation. It's a fancy name, but I'm just trying to emphasize the fact that it's protective and that it's something the body does on purpose, just like cancer tumors, just like metastasis, just like cachexia. This is yet another protective adaptation that the body does in order to protect itself from oxidative stress. It downregulates oxidative phosphorylation, which is a particular process in the mitochondria, and that prevents mitochondrial overload and allows the cancer cell to act as a toxin storage unit. And it once again reduces the internal production of ROS. So, okay, so those are the three key points. Like I said, I reinterpreted the Warburg effect, I reinterpreted glutamine addiction, and I reinterpreted mitochondrial dysfunction as mitochondrial downregulation. So, there's a couple other points, which is that, like, also, Seyfried sometimes talks about how cancer cells basically metabolize lipids differently or handle lipids differently. But I just point out the fact that, well, that's because they're trying to detoxify seed oils and other toxic lipids, PUFAs, polyunsaturated fatty acids. That's a minor point, but nevertheless, we can reinterpret how they handle fats also as detoxification as well. So yeah, I think that kind of sums up basically my view on the metabolic changes that happen inside cancer cells. Like I said, I'm viewing them as not something that's broken with the cells. It's not that the cells are broken and dysfunctional. It's that they are built to be storage vaults. And whenever you're building a cell to be a storage vault, you have to change the metabolism. It doesn't work if you try to run the same metabolism surrounded by toxins. You're going to generate tons of ROS. It just won't work. So, okay, so that sums up the metabolic changes. And then, next I'll talk about another phenomenon, which is very interesting, and it's called spontaneous tumor regression. And this can actually give hope to people who, might have have a tumor and they hope someday to not have it. And, I have said, by the way, that tumors are not the true enemy. It's toxins that are the enemy. And so if you want to be afraid of something, you should really be afraid of toxins, not tumors. But nevertheless, it is true that many people who have a tumor want to get rid of it, and they might want to know, what do I have to do to get rid of this tumor? And of course, you can go the standard path of attacking the heck out of the tumor, with harsh chemicals and radiation and all these things. And those things can get rid of the tumor, but it causes a lot of potential damage in the process. And is that really the way we want to go? Because if cancer tumors are full of toxins, what happens when you destroy that tumor? Like, all the toxins go into your body. They're released into your body. So that's not really what we want to see happening, right? So I just want to talk about a very interesting phenomenon that has been observed in the medical literature called spontaneous tumor regression, STR. And this is real. There are cases documented in the medical literature that date back a century of basically people who had a tumor, had potentially a large tumor, and then that tumor either dramatically shrunk or just disappeared without any conventional treatment, without any actual standard medical treatment for it. So what would make that happen? Well, there's certain, and by the way, there's a 1956 article called "Spontaneous Regression of Cancer," a preliminary report, and that reviews this phenomenon. And they talk about some sort of triggers that lead to spontaneous tumor regression. The first one, as you can guess, is a dramatic lifestyle or dietary change. So when the patient has a dramatic change in their lifestyle or their diet, then this can happen. Another one is that it can occur either during or after pregnancy, if you're a woman. Another interesting one is that it can occur after sudden onset of a high fever or severe infection. And I'll dive more into that one in particular. But it can also come from, as you would expect, removal from a highly toxic environment. So whenever the patient is in a toxic environment and then they get removed from that environment, spontaneous tumor regression can occur. And sometimes it occurs even without any obvious trigger at all. So those are sort of 5 triggers for this. But the broad theme of spontaneous tumor regression is that it occurs whenever someone is initially in a high toxic load situation, and then the toxic load is significantly reduced, maybe through various means, either through, say, lifestyle or diet or some other reason, and then finally the tumor just regresses. And there are, like I said, documented cases where this has happened. Now, how does the mainstream view this STR, spontaneous tumor regression? Well, they think of it as kind of like a miracle that they can't really explain very well. It's like a magical miracle, and just it's a sort of rare miracle or a statistical anomaly. Sometimes they might say, well, maybe it's just that the immune system finally figured out that the tumor is an invader, and then the immune system attacked it, and then it disappeared. So they sometimes will say that it's kind of like the immune system finally waking up from its sleep and deciding to attack the tumor. Now, of course, this raises some weird questions, right? Like, why, number one, does this regression happen in some patients but not others with similar tumors? Why is this regression often linked to major reductions in toxic load or lifestyle changes? If it was a miracle, then why would it be linked to actual lifestyle and dietary changes? And then, and also there's deeper questions, which is that the body provides resources and support to cancer tumors in the form of blood vessels and infrastructure. And so the mainstream view doesn't really answer that sort of question, which is why is the body providing favors to the tumor? And then similarly, why is the cancer tumor providing favors to the body by sequestering, storing, and processing toxins? So that's the deeper thing that the mainstream can't really explain there. But okay, so within my theory, toxin sequestration theory, how can we view spontaneous tumor regression? Well, it's pretty simple. Basically, we view it as like the body decommissioning its storage vault whenever it doesn't need it anymore. Basically, the body constructs the storage vault when it really needs it, and then when it doesn't need it anymore, when the toxic load has been dramatically reduced, the body says, okay, we don't really need this anymore, so let's break down the tumor and dismantle it, and then sort of empty it out. So that's the basic idea, and this explains why the regression occurs often after major dietary changes, reduction in environmental toxic exposure, and significant improvements in, say, detox capacity as well. So now, how does it actually happen, sort of step by step? Well, that's kind of interesting. It like I said, step one is the toxic load gets reduced somehow, either through lifestyle or diet, and then step two is that the cancer cell's metabolism will start to revert back to the normal metabolism, because now there's no longer a need to have this downregulated mitochondrial function, so it starts to go back to a normal metabolism. It shifts from this anaerobic to aerobic metabolism. And then, the third step is that the body starts reducing the blood supply to the tumor. So the blood vessels start to retract and this tumor starts to shrink. And then we start to have step four, increased apoptosis, that's cell death, where basically the cancer cells will just basically die. They'll commit suicide, whatever, apoptosis, and they will basically burst and die. And then after that, step five, the final step, is the immune system clearing it out. Basically, the immune system will remove the cellular debris from the old cancer cells, and then remodel the area with normal tissue. So those are kind of the 5 steps. Like I said, it's kind of intuitive, exactly what you would expect. It's basically a decommissioning process where the body no longer needs this vault. And there is, like I said, evidence supporting this view. Like I said, number one, the common triggers of spontaneous tumor regression is, number one, major dietary changes, which removes all these ROS generating toxins that people are eating. And then, number two, removal from toxic environments. So whenever you're not exposed as much to industrial chemicals, pollution, molds, then that obviously reduces your toxic load. Your lifestyle improvements, lower stress, better sleeping, etc. That also helps out. And then, an interesting one I would say that I mentioned at the beginning was high fevers. And you might say, well, what's going on with that high fever one? And I do have a hypothesis there, which is in line with a medical researcher named Garrett Smith. He believes that high fevers are actually detoxification events. Now, of course, many people would associate high fevers with infections, but Garrett Smith has an alternative view that high fevers come whenever your body is detoxifying. And so he refers to this as a toxic bile dump, where the body dumps bile out of the liver. The bile carries toxins, and this causes stress to the body. And so during that stressful detox event, your body is stressed out. And I'm not sure exactly how the fever comes into play there, and I'm still investigating that. But nevertheless, according to Garrett Smith, these high fever events can correspond to detox events. So you can see why a high fever might precede something like tumor regression. And the broader picture is that the body initiates tumor formation during periods of ROS overload. So whenever the ROS levels in the body exceed the ROS budget, then that's when the body forms the tumor. And then conversely, whenever the ROS load actually dips below the budget, the body says, okay, well, we don't need this anymore. Let's decommission the tumor and break it up. And the body, by the way, does have a sensing mechanism for the local ROS levels. It can sense these things, so it knows how much oxidative stress that it's under. Yeah, so that's basically how a tumor is formed and how it is regressed. And then, of course, naturally, this suggests a very hopeful way to heal and encourage tumor regression by focusing on the root cause. Try to reduce the toxic load that you're experiencing. Change your diet to a good diet and support your body's natural detox systems, and potentially be cautious with aggressive approaches that really try to attack the tumor with oxidative stress, because from my perspective, that is adding to the toxic load. So that basically summarizes spontaneous tumor regression. And thanks very much for listening. Let me know your thoughts in the comments.